Okay, so we hear a ton about the wild potential of AI, right? But today, we're going to get real. This is all about how governed AI systems actually behave in the real world. What's being built when safety and reliability are everything. Right off the bat, let's be super clear. This is not some flashy demo. We're not looking at a perfect, curated little scenario that's just designed to look good. Nope. We're digging into the real architecture of a system that's actually out there working. And hey, this isn't a roadmap either. There's no coming soon or wait for the next version here. This is about the principles and the practices that are being used right now to manage this incredibly powerful but, imperfect technology. And this is probably the most important part. This is not a promise that everything's going to work perfectly. Actually, it's the total opposite. This is about systems that are designed from the ground up with the understanding that AI will fail, and we have to be ready for that. So, with all that said, what's the actual problem we're trying to solve here? It's not just that AI is, unreliable. We all know that. The real problem is way, way more subtle. It's that AI fails quietly. Let's really break down this idea of quiet failure. Think about it like this. Imagine the engine in your car is slowly losing power over months, but every single gauge on your dashboard still says everything's perfect. See, the system doesn't just crash and burn. Instead, its outputs just drift. They get a little less accurate, then a little less, and a little less. But here's the really scary part. Its own reported confidence stays sky high. It's failing without ever raising an alarm. And this right here is a really crucial point. It means our main goal totally shifts. We're not just chasing after the highest possible accuracy score. We are engineering for failure containment. The whole system has to be designed to limit the blast radius when, and I mean when, not if, a component goes off the rails.
Okay, so how do you actually build a system that can contain failure like that? Well, the answer is in something called a governed flow. A governed AI system isn't some magic black box. It's a really carefully structured, step-by-step process that's designed for maximum control and visibility.
And this flow, this is the absolute heart of the design. It kicks off with a structured intake. Then, the context gets strictly bounded. We don't just let the AI run wild. Only then, in step 3, does the AI generate something. And notice that word, provisional. It's just a draft, a suggestion. That draft thing gets evaluated separately before it finally lands at step 5, the human decision. That's the most important part. So these are basically the non-negotiable rules of that whole process. Nothing happens by accident. The context is totally locked down. The AI's outputs, they're treated as just suggestions. And the most critical piece of all, the AI never, ever gets the final say. A human is always the one who decides what actually happens next. This brings us to the rules themselves. Governance isn't some policy document that just sits on a shelf collecting dust. In these kinds of systems, it's actually designed right into the architecture. Think of it like a set of hard-coded boundaries, like digital guardrails. Let's take a look at how these boundaries actually work. There are 3 really clear zones. First, in the allowed zone, the AI can create provisional stuff, like drafts or summaries. But the second it produces a recommendation or an interpretation, boom, it moves into the requires human review zone. And then you have the prohibited zone. This is for the absolute no way, never stuff. The AI can never execute actions on its own or just silently declare its output to be the truth. Look, if you only take away one thing about these rules, let it be this. There is an unbreakable wall between what the AI produces and any real-world action. The AI can suggest, it can analyze, it can draft all day long, but it can never, ever pull the trigger. Okay, so with all these rules in place, what does this actually mean for the person who's using the system? Well, their role changes in a really fundamental way. They're not just an operator anymore, they become a supervisor. And the supervisor's job is really a highly skilled. We're not talking about just pushing buttons here. They are the ones defining the boundaries the AI has to work within. They're inspecting its outputs for any weird variances. They're actively hunting for that quiet drift we were just talking about. And ultimately, they hold the final responsibility, deciding when the automation just isn't safe to trust anymore. And this supervisor role is so critical because it's our #1 defense against one of AI's most famous problems, the confident hallucination. Right? When you have a human supervisor as that final checkpoint, an AI's convincing piece of fiction can never just be silently promoted to become an operational fact. This human-centric design leads us to the main takeaway. Building systems this way isn't just about, being responsible. It's a survival strategy. If you want to build something that lasts, you have to govern it right from the very start.
This really represents a huge paradigm shift. The old hype was all about AI replacing human judgment. But the governed reality, it's that AI amplifies human judgment. It's a powerful tool that makes an expert better, faster, and more capable. But it doesn't take their seat. And the benefits of doing it this way are just immense. For one, it prevents what you could call silent authority laundering, where people just start blindly trusting whatever the machine spits out. It also creates systems that are totally auditable. You can actually trace back and explain why a decision was made. And maybe most importantly, it ensures safety and stability for the long haul.
So as we start to wrap this up, I want you to let this thought really sink in. We are so often obsessed with finding the biggest, the smartest, the most capable AI models out there, but that's really only half the picture. Because the systems that are actually going to survive and be trusted in the long run, they aren't necessarily the ones with the smartest models. They're the ones that have the best frameworks to govern, supervise, and contain them. That is the future that we're actually building.